Every college should have their demanded program and course. Their demand will be to get opportunity to study the latest technologies. If they find that in Santhigiri College, Santhigiri College has required the standards and the subjects of their choice, they will certainly land in Santhigiri College. Otherwise, they will search for other institutions in any part of the world that suits their wished career. If you, as a teacher, is to be demanded or selected by the students, you should be a person capable of teaching the courses that they look for. If only the teacher has proved and reputed as an expert of that subject with attractive teaching methodologies, students will opt for your classes from any part of the country or world. And here is the importance of conferences of this kind, where you can study the latest technologies. Today, we are conducting an international conference on advanced computing and communication technology. Advanced computing means technologies used in the designing and developing of computing hardware software. Communication technology is the transfer of messages or information among people or machines through the use of technology. This international conference will certainly emulate and enhance the computer learning of our students and staff with a novel subject base. Only updating of computer knowledge outside the university syllabus, utilizing opportunities of this kind, will widen the knowledge spectrum and make our students and staff at par with the contemporary technology and advancement, ensuring the furtherness of higher education. I take this opportunity to congratulate the Department of Computer Science, especially Dr. Deshmi, for organizing this international conference. The Department of Computer Science is the biggest department in Santhigiri College, and it's a model for other departments in initiating new strategies and learning tools. I'm also happy that Dr. Raju is with us today, especially because he's from Christ Bangalore, which is a CMI institution. I wish all the participants a fruitful day, and may the Almighty God bless all of us. Thank you very much.
Thank you so much, Father, for your enlightening words. Now, I invite Ms. Amita Joseph, Head of the Department of Computer Science, to invite for a detailed introduction regarding the chief guest of the day.
Good morning, everyone. It's my privilege to introduce our chief guest, Dr. Raju, to yourself. He received his PhD and MCA from Kerala University and MTech from MS University, Tamil Nadu. His specialization includes image processing, data science, and machine learning. He has more than 30 years of teaching and 20 years of research experience. He has published more than hundreds of research articles in different national and international journals, and he has guided more than 20 PhD scholars. He served as the Dean of Faculty, Chairman, and Board of Studies, Head of University Department, Kannur. He is a recipient of IBAE Awards, Distinguished Educated Award. He is a member of CSI and IEEE. With most privilege, I welcome Dr. Raju to our conference. Thank you.
Thank you. Thank you, madam. Am I audible?
Thank you so much, Miss. Now, I invite Professor Dr. Raju, sir, for your speech and your talk. Please, sir.
Am I audible?
Yes.
Oh, thank you. Thank you. Very good morning to all. Respected Reverend Father Paul Parekatil, the Principal, HOD of the department, Professor Anita, other faculty members of the college, distinguished guests from other colleges as well as other institutions, and my dear students. I could see many students are sitting in the hall. So my sincere thanks to the organizers for inviting me for this August event. Also, I'm very happy this. I know this college about 10 years back. One of my students' husband was working there, and through him, I came to know about this college. And since it is a CMA institution, I am also working in a CMA institution. I know the trust given for quality in Santhigiri. So we are in a what you call in a very crucial phase of teaching learning process, because after 2 years of pandemic, I'm very happy to note that students are back into campuses, and we started the so-called offline sessions. And you were missing many things from campus, because the community living, the peer learning, and the direct interaction with faculty and all. And but nowadays it's a very challenging situation for faculty as well as students to go back to the same academic vehicle. As Father rightly pointed out, the world is changing, and our education system is lacking much behind. There are many reasons for that, but still we have to compensate with how, as a student, how as a faculty, we can overcome the restrictions or the frameworks which make us what you call going back in time. For example, when it comes to computer science and where it stands and where it stands 30 years back, there is a huge difference. I started learning computer science in 82 or 83, if I remember correctly, maybe 84. But from there, if I analyze the curriculum, the mode of teaching, and the exam pattern, there is not much difference, I must say, especially in Kerala. But there are institutions where they update the syllabus, update the evaluation process and all. But otherwise, we have a great challenge ahead. As students, you have great challenge ahead to raise, so that you reach a level so you can compete with the others from good institution. Again, Father referred to NEP, New Education Policy. And one good thing I noted, because in my state, that's Karnataka, they already started the implementation of NEP. It's not very easy to implement. There are so much of confusion, especially from the faculty point of view. We have some issues, as rightly pointed out. We have to be more prepared. The students will be more demanding when if NEP comes, because they are the people who decide what to learn, from where to learn, how to learn, kind of thing. Whether I should take continue in one institution, multiple institutions, single course, multiple course. So you are the people who decide. So that is a very good move if at all it is implemented in the right spirit. But there are what you call in any new system, there will be pros and cons. So I'm not going into the advantages and disadvantages, but there is one point which I wanted to stress, is the importance given for research in UG as well as PG. PG, of course, now also we give some importance to the research concept, but they are bringing it down to the UG courses. Means, Rashmi, Rashmi, can you start that PPT? Okay. Am I audible? Yeah, next. Next slide. Yeah, the reason. No, go back. Yes. Yeah. The reason for bringing it down to the UG level is catching them young. So I started my research career at the age of 34, 35, that range. But now I feel it is too late to start a research career or research. And the enthusiasm and the way the people approach the problem, contribute to a problem at the age of 20s or early 20s is much different from the way we contribute at a later age. We may be an expert in some area, but we may not be that good in coming up with what we call new solutions or new findings. And this is the age, the early 20s is the right age to start the research process. So that is one good thing. And again, they're recognizing if you go for a 4-year bachelor's, where the last year will be on to research, and you can directly go for PhD. And later I will emphasize why people are stressing on this so-called PhD degree. Okay, next. And move up. So I'm not going to give a formal definition or a class on research methodology or varsity research, but in general, we can say research is related to some innovative ideas based on your knowledge, expertise in an area, which may lead to some products. That is how we have a new products appearing every day. You can see if you search Amazon, or if you go to a hospital for treatment, you can see new products appearing, new methodologies, new procedures appearing. So it's all because of the innovative ideas. Then nowadays, the people are going for patents. Earlier, that rush was not there, because since the academic accreditation institutions what to call identified patent as one criteria. Now people are after patent, but basically patent is a very an activity where when you can protect your rights. Okay. And in our in department, there are many students, they go for patent. Already there are many student patents published, and there some are about to be awarded also. So as I mentioned, this patent, the and publications, these are all part and parcel of this the process of research. And as undergraduate as well as postgraduate students, you should aim for this patents and publication. What is patent? You should read what is how to go for a patent, or should I go for a publication? They are two different things. And how do I do a good publication? All these things should are part of the concept of research. Next. Now we can look at the research from different perspective. It's a way of learning things. Research teaches how to learn, or a systematic approach to solve problems, or it can be anything like a day-to-day solving day-to-day problems, and can be in academic research, can be industry-based research, or nowadays we combine them. Earlier, these two were two different compartments. Now it is integrated, academic and industry research, because academic industry people come to institutions, we collaborate with them, we do joint research, and that will be converted to products, and you will be recognized two ways from the product, that patents or whatever they get, as well as a monetary benefit also. So that is the industry academic collaboration for research. And research is not limited to allied people. You know that what the figure shows is a series of what you call so-called the research coming out of the need by a common man. Okay, so no degree required. This is mostly spontaneous. These people are not trained for doing research, but still they do it. Okay, that is different. One in maybe 10,000 or one in lakhs may have that kind of a what you call bend, research bend. Okay, next. Now, when we talk about research, is it the same for what you call everywhere? The methodology or the steps followed? No, it is domain dependent. Probably sometimes we say problem dependent also. When I say domain dependent, we are into the computer science and application domain. And the way we approach, select problems, identify problems, with the way we solve problem, we what you call discuss problem, all these are different from a person who is doing research in physics or in commerce or in business management or in sociology or in medicine. Okay, so we have to inculcate that that philosophy. What is the methodology which I should follow? Probably there is no single methodology. There can be books on research methodology, but I don't believe in that. There is nothing like a single series of steps like an algorithm you can say research means step 1, step 2, step 3, like that. It is a process which we imbibe through experience. So you jump into it, it will you will find a methodology to proceed with. That is research methodology. Okay, but there are certain frameworks, certain approaches which are common. That is normally we cover under the concept of research methodology. But by doing research, you learn the skill of going in depth. Normally, you know that our subject or any subject in matter is an ocean. So how to go deep into the ocean, we need a skill. And by doing research, actually, you will acquire that skill of going in depth. Then obviously many of our courses focus on problem solving skill, mathematics or in computer science or in programming. We address this skill, but still by doing research, you will be in a higher level of identifying and solving problems. And many a times, in our academic course, the problems are given to us, but in research, we find problem and we solve. Then obviously, when it comes to computer science and application, mostly we will be doing low level or at least middle level coding. That will also improve your programming skill, and you will be doing identifying some new programming tool, language, and you will be working on it, and that will definitely improve your programming skill. Critical thinking, it is actually the backbone of the entire process. So whenever you read a paper, whenever you listen to someone, you have to think critically. Critical thinking only will lead to new things, new knowledge. Okay, so you will be trained by doing research and academic research. You will be trained for critical thinking. And another outcome of this is technical writing. Far from our conventional writing. Say, 2 days back, I was correcting a project report, and I could find a lot of mistakes in that the report, the sentences. What is that? They started learning from LKG or even before LKG, because most of the students are from outside their native place. So they live in that language only. Their mother tongue is, you can say, it is English, but still they fail to write a technical report. So writing technical report, again, you have to learn. There are certain do's and don'ts for technical writing. There are many good sites, many good tutorials. You go through it and you will learn how to write a what you call on your own. So that skill also will be learned if you really do a research work. And finally, in conferences or in symposiums and all, or even in classrooms, we will be presenting our output, my findings or my conclusions. So that presentation skill, these are some of the skills or the advantages you gain by doing research. Next. Now, today my responsibility is to give an introductory talk and not a technical talk about the conference. As Father rightly pointed out, these conferences help us as students to do a lot. You learn many things, starting from the organization of the arrangement, the organization of the conference, to the paper presentations, listening to the conferences and all. So regarding this, what is basically conferences? In conferences, what is happening in conferences? People present their ideas. So they write a paper based on their findings. The idea can be totally new idea, something which they found during their journey, or it can be a reiteration of knowledge, new knowledge. Somebody has come up with or recently some finding is there, some new models is there, some model is there, new device is there. See, for example, how many people are still not aware of the that we can have a system without a hard disk. Okay, so that the technology, because unless we read magazines, journals, or listen to someone else, it is very difficult to get updated, because that is the scenario. Every day new things are happening. So new knowledge can also be shared in conferences. You identify some new knowledge, you put it in your way, in your words. not copy some what you call journal or things and present it, but in conferences they present new knowledge from their perspective. Then the ideas, I present one idea, you can analyze the idea and you can give a critical comment about my idea. That is, these are all that what is happening in conferences. Or you can have a comparative analysis of 2 3 or more, just like we have comparative analysis of products. When you go for purchase of say a mobile, we do this, isn't it? Similarly, there are many ideas proposed by many researchers, and you can have a comparative analysis and you can come to a conclusion. That is, these kind of discussions are happening in conferences. And when you as a presenter give a presentation or submit a paper, it will be peers will be evaluating it. Peers means people who are of your level, who are maybe experts in that area, who are working in that area or having experience in that area, but we consider them as peers. They are no one like a above or below, like peers. So peer evaluation always, like for example, in your class, when you present a topic as a seminar, your classmates only ask questions, they only evaluate you. Okay, ultimately the faculty may give you marks, but the evaluation actually happens from your peers. Then critical evaluation, when I present something, you can critically analyze and you can give your feedback. That will help me to what you call to modify my work, to incorporate new things, or to identify my mistakes. Okay, so critical evaluation is happening there. Then very important one, connectivity. See, yesterday also my HOD was telling me, sir, you have to identify 5 industry, I mean 5 organization, and start building network connectivity so that our students can go for internship in those organizations. Same thing here. When you attend a conference, there will be people from outside, maybe across the state, across the country, or across the globe. Or maybe this time you may be organizing in a humble way. Next time you may go beyond this, and there will be more participants. There will be more experts coming into your conference. You have interaction with them. You get a like you have LinkedIn. You can have a connectivity. You can identify people. You can discuss face to face discussion is much more effective than what you are doing through online media. So you can form research groups, or you can be part of a group, or you can have a connect with the people who are experts in your area. So that also is happening in conferences. Then this kind of connects leads to joint works can be like you have you can share. No, normally we promote it in academics. You go and find a partner in India, abroad, and do a joint research that is considered as a very significant part of our career. Joint work, joint publication, joint patent, joint what you call supervision, whatever it may be. So these possibilities are more explored during such our conferences. So I, in that context, I appreciate the organizers for conducting this international event, providing a platform for your students as well as the students are faculty, researchers from outside the institution to exchange their knowledge with others. So my heartfelt congratulations to this the organizers. Next. Yes. Now, in tune with the new education policy, or even before that, there was a a decision from a university commission that all just should a PhD holder, and that is that they are making it a mandatory. So first thing I tell you, then there can be many questions can be asked from your side, a student side. Why then many faculties are without PhD? See, uh, this the availability of infrastructure, the supervisors, and the support from the university, support from institutions. This happened only in the last few decade. Decade. So during the say in 2000s or 90s and 2000s, it was not that easy to get into research. The culture was not there. See, after getting a master's degree, you can straight away go and become a teacher. And probably some teachers may go for MPhil. Out of their interest, they used to go for MPhil, and some may go for PhD due to reason. Later on, UGC linked this with the promotions and career advancements. The people started doing is only for the sake of career advancement kind of thing. I mean, I'm not generalizing it, but generally it is related, combined with the career advancement and recognition. But when it is a minimum qualification, it has become a mandatory thing. Why? The reason is we want youngsters to be trained in research methodology. Okay, they should be doing research as part of their course, a mandatory thing. Then, if that is the case, our faculty should be first trained in the research methodology. So they should all. So PhD is basically considered as a course where you will be trained in research methodology, how to do research in your particular domain. Okay, so whenever you do research, do it with a passion. Then you will enjoy it. Never do it for the sake of completing your degree. Never you do it for the sake of getting that DR in front of your name or for getting some promotions and all. Do it with passion. And as I mentioned, there is nothing like that. Only the cream can do research. Anyone can do the research, provided you are ready to work hard, focused, and there should be an appropriate a mentor who can handhold you through the journey of research. And we as maybe from our experience or we push this concept of that research should be part of courses. See, for example, if I am offering a course on, say, operating system, okay, I'm not very good in that course, but still, operating system, if I am offering a course on operating system, I should put across the students some problems which are research oriented. So end of the course, you will be working on that problem and you will be coming up with, need not be a novel contribution kind of thing, but you will be coming up with some critical, say, comments or sometimes some very novel model idea as part of the questions which I put across. So so you consider, rather than considering the what you call end semester exam questions or your other CA or what you call the test paper questions and all, you consider it as a research problem. And when you consider it as a research problem and when you solve it, your involvement will be more, the learning will be more, you will become a totally different person and with a different perception. So that is why research should be part of at least few courses of your UG and PG degree. And slowly it will come. And so your generation should be prepared to do these kind of things. And project-based learning, it's already implemented in many places. Say the moment I teach data structure, and if I discuss the concept of say stack and queue, I should find a suitable project, so that you implement the project, and by doing that, you learn what is the use of the stack and or stack or queue, whatever it may be, rather than learning what is push, what is pop, how do I write a function for push, how do I write a function for pop. That is not important. What is it and how do I use it? Where can I use it? How can I develop an application using this? That is more important. That is called a project-based learning. So as you move forward, maybe because you are in early 20s or late 90s, what you call, you are the right age to identify these things and prepare yourself for this. Next. Yes. Research is universal. So unfortunately, we are meeting in online mode, because if it is offline, I would prefer coming offline because of the what you call the time or the distance or other issues. Because whenever we have an interactive discussion, this is more productive. Because unless it is a technology, if I discuss a technology, obviously there will be a technical component, new something which is new coming. Okay, let us move to my next point, that Whether research is academic oriented? No, research is universal. As I already shown you one slide where research is happening while climbing a coconut tree, how people invent different methodologies or devices or approaches to climb coconut tree. So that is research. So we have academic research, we have industry research. You know what is the significance of industry research? All this, all what we enjoy today, they are basically because of these two: academic research and industry research. In academic research, we initiate something, some basics. For example, it can be some algorithms, or it can be some new hardware, suggestion for new hardware, but we may not be implementing it. Whereas industry, they may have separate R&D wing. On almost all industry, they have a separate R&D, research and development wing, and many a times they make use of this industry, I mean the academic research, the result of outcome from the academic research as their base, and they do research so that the concept is converted to a product. So that is basically industry. They are focusing on product based research. In academics, it can be product based research, or it can be this knowledge for the sake of knowledge, or it can be something what you call something which is added to the existing knowledge but may not lead to a product. But in industry, obviously we focus on, and in government also we do research. For example, the financial things, the planning, we have a planning board. There also we are doing this research. We have R&D. Okay, anything we enjoy today, they are all the fruits of research happened years. Next. Now, by doing a research in UG or as a PhD program or as a PG, what is ultimately will they be doing, considering what is the opportunity I get, career opportunity I get? I tell you, there is a great demand for research degree holders in industry. There is a great demand. Okay, so the moment because they expect a lot of, see, basically we say education is modification of behavior. There is a good old definition of education. So your behavior will be modified by doing research such a way that it will suit their requirement, industry requirement. That is why the industry people are looking for people or the candidates with a research bent of mind. Okay, it need not be a PhD degree. Even in UG program, even in your BCA program, you can do it. You can come up with some publication, and those publication will help you definitely to identify yourself, or to to give a additional thing in your career. Then the PhD, as I mentioned, it has become like a degree, like a PG degree. Now, there are institutions, especially abroad in European countries and US and all. They offer postdoctoral fellowships. Many of us are going there. Many of my colleagues or my one or not two of my students also, they join for this postdoctoral research. What is postdoctoral research? Once you are trained for doing research, people will extract from you. You have to contribute by what you attained during your training. You should put it across so that you come up with a more refined or more focused kind of research. So in industry also they call for this postdoctoral research. In academia also we do it, and there are many scholarships. They get better salary than better what you call compensation than the faculty what we are getting. Okay, so postdoctoral research is an option. Then as I mentioned, industry, then projects. So government float projects, some R&D organization float projects, and I don't know whether your institution has already taken some projects from ICACC or UGC or some other funding agency. So funded projects are there, projects given by industry people are there. So many projects you will get. It can be like a development project. Already in your institution you have that facility, that facility for development project. So research projects are also similarly given to us. So if you have that training, you can go for this research projects. And finally, for teaching, it is now a mandatory thing. Next. Okay, so for I was discussing some what you call very general idea, what I felt like sharing with you regarding research. Now, I thought of discussing a very small, not much time I do want to spend on this, but only a few minutes on a very hot topic called artificial intelligence. And why I choose this topic is because of this significance of it in almost all aspects of, say, our day-to-day life. It's going to be like that. Okay, so my first question is, you might have, I mean, there is no introduction required for artificial intelligence because we know it, because in our mobile or many devices, we know this, the concept of artificial intelligence is already there. So, but as in a BCA student and MCA student, the question you can ask is it mandatory to learn AI to survive? We have the habit of jumping into same well, that is, if somebody says AI is the current technology, all people will go and start learning AI. No, that is not the right approach. In fact, we require people the industry require people who are good in other aspects. For example, there is a scarcity of people who are good in user interface design. So we nowadays people call us user experience, because the to attract people to a software or even an operating system or a device, the experience should be good. User experience should be good. So how to define a good user experience? The talent required is different. Some of you may be very good in that. So you can focus on it. You can get more trained in that. That will fetch you a very good job with a very good compensation. Even the application development, great demand is there now. Now also there is great demand. So, or mobile application developments, we have a great demand for this. So it is nothing like that we should have AI to survive. No, it should not be like that. You don't simply, if you as a BCA or MCA student, don't give only significance only to the AI kind of thing. No, you should be good in programming, good in software engineering, should be good in what you call user interface design, or should be good in what you call these all aspects of the what you call programming and software development. Okay, and not all. Where you have interest, you can go for it, but my question, if I say the same question again, is it mandatory to learn AI? I may say yes. It is contradictory only. So certain problems are always like that. You get both answers, no as well as yes. Here I have a yes. The reason is AI is embedded into almost all applications, whether it is web page design, whether it is a mobile application. So we are slowly moving to a situation where AI is becoming indispensable. Okay, so even when you are going for as a, or you are working as a user interface or user experience designer, a knowledge or some level of expertise in AI will surely help you. That will be an added advantage. So I request all of you, all BCA MCA students, to have some exposure to certain concepts of artificial intelligence. So then next slide. Next. So let us uh, see what you mean by artificial intelligence. Classical definitions are there. We are leaving aside those definitions and concepts. So mainly from our point of view, the intelligence come from vision, means from a machine perspective, we take images, videos, and we learn something from those images and video, and ultimately that system become intelligence based on what data, what video or what image data we capture. Okay, we can view it like this. Or speech, you are familiar with the speech recognition systems. We are using it, most of us are using it. So there also the data comes in the form of speech. We call it as speech signals, and ultimately all are digital. But there will be some mechanism with which we analyze speech, or to recognize speaker, or to recognize the speech, or even to synthesize. While giving answers, we do the process of speech synthesis. So on all this, intelligence is required. So that intelligence is captured through that speech data or text. So text data is nowadays very common. The moment you type or what's in WhatsApp or in YouTube or wherever you have what you call social media data, we consider it as a text data, or the conventional say mailed the data, or the text data available in the form of DBM as part of DBMS. All these are text data, and they are also sources of knowledge. So AI is all about coming with about learning from this data. And there is a classical AI concept. I don't know where your syllabus is focusing on, to whether you learn AI or whether your syllabus is focusing on classical AI, which is knowledge representation, searching of solution and space, etc. So it is a very vast area. AI is a very, very vast area covering a lot of things, including so-called robotics, machine learning, and so on. But classical AI, what is the concept? I mean, in 80s when I was a student, we learned this AI as a paper, but there wasn't much practical application for that. It was not a success those days. There was a concept called expert system, and in late 80s, people projected that expert system will be ruling the world. Nothing happened. That was a not that a successful model. But you know that. Next slide. So as we moved, this AI has become more focused on data. So ultimately, the problem is has become like a intelligence from data. We people started looking at AI as the intelligence from data. I mean, this is one perception. There are many other ways by which I can discuss the same topic. So intelligence from data, like a customer data, sales data, patient data. So you learn from this data. And data can be what already as I mentioned, the data can be text, image, video, and whatnot. And it can be structured, like what we do it in DBMS class, structured data, or it can be semi-structured like our email, where some structure is there but not everything is structured, or totally unstructured like our WhatsApp messages, no structure. Okay, so now AI is all about. I mean, one perception of AI is about generating, I mean, bringing in intelligence by looking into data. And related to this, you might be using this concept of SQL and NoSQL, where which one is suitable for structured, semi-structured, unstructured, and all. Next. So what is data? And from what is the data, we extract knowledge, and then this knowledge will be used to solve new problems. That is what is happening with the AI. So knowledge generation, using that knowledge to solve. What is the use of the gaining knowledge? So when you encounter a new situation, how do you react, or how you solve the problem? So for that we make use of the knowledge. So how do I generate knowledge from data? Thousands of methods are there, thousands of ways by which I can generate knowledge from data. And one broad umbrella is machine learning, which is nowadays we call it as a subset of AI. And if you ask me personally, if I say AI, the general compared to the classical AI concepts, nowadays people are more into machine learning. Machine learning. Okay, next slide. Okay. So I'm sure most of you are aware of this machine learning, if at all. If not, I will towards the end I will conclude with that discussion on that. But machine learning is broad umbrella with a lot of what you call methods and methodologies and models. So there are tasks, approaches, models, etc. of different category. We cannot learn all. So that is where the expertise should come. Which model, which approach, which task I'm solving, which approach is the best suited for that. So that is where your expertise should come in. Okay, then recognize what are the tasks we talk about. Sometimes it can be recognizing people, that face recognition we are using day one, or your thumb impression is a recognition problem to authenticate you into your mobile. Then we have classification problems, where the machine classify the given data into one of the groups. So there are many applications. For example, given an say the X-ray image, say X-ray chest image, a classification problem can be to identify some abnormalities in the chest image. So that is the question asked is whether there is an abnormality, whether there is a lesion in that image or not. So that problem is called as classification problem. There can be a grouping problem, clustering problem. So identify, say for example, we have hundreds of customers associated with my business. I want to cluster them for some purpose. I can go for a grouping. So I don't have a specific label for grouping. Whereas in classification, I have a kind of rule. For example, in the class, all students with a height less than 150, I call them as short. Don't consider it as body shaming, but short, and others as medium, then as tall. Then it is a classification problem where I have a rule to say. But in group, I mean, a label to paste on you. You are short, you are long, you are medium height. Whereas in grouping, no such predefined models are there. We simply group them based on certain attributes, and we call it as a process of clustering. These are some of the machine learning operations we generally perform, but not limited to this. And this, all machine learning application models or approaches are built over certain learning theories. Certain learning theories may be visibly or invisible, because visible or invisible in the sense that we may not be bothered about what is the theory behind it. We need not, but they have a footing on some learning theory. It can be a formal theory or informal theory. Next. Okay, I'm skipping this. What is machine learning? Is basically we analyze data and get some information. So moving next, you can move to the next. And many of you know what are the ways by which a machine learn. The way we learn things. Most of the learning happened during our early days. Say when you are 6 months old, or 1 year old, or 2 year old, 3 year old. I mean, up to say 2 years. Most of the learning happens through unsupervised learning. So unsupervised, and slowly it becomes like a supervised. And in schools and colleges, mainly they are supervised learning. But basically, from machine learning point of view, we have a totally different approach. For example, next slide. So this is called a classification problem. I consider this as a classification problem. Ultimately, my aim will be to build a software model which will take an input and output a class label. Okay, that is a classifier. So we call it as a model. So then for the model to classify accurately, I must train it. So it must learn. So that learning can be happen in different ways. And this particular model, we call it a supervised, in the sense we will give show the picture of apples, and tell the model that these are apples. So it learn to identify, say, different type of apples you can give, different texture of apple you can give, different sized application apples can be given, and you would make it learn. Always you tell this is an apple, this is an apple, this is an apple, and after showing several apples, your model should be such a way that it learn what is an apple, so that tomorrow if you are, or later if you show a new fruit, it should identify whether it is an apple or not. So this kind of learning is called supervised, in the sense that we train by saying that this is apple, this is apple. Next. This is what I said during our early years, say 5, 6 months or 1 year. This is an observed theory. I mean, observed fact. If you give toys and all to kids, they at some point of time, if you observe, you can see then they are separating it into different categories without any instruction from your side. Sometimes if you give some three-wheelers, two-wheelers, four-wheeler kind of toys, without much intervention, some point of time, you have to observe them. At some point of time, they will be separating it into two-wheelers, three-wheelers, and four-wheelers. And it won't continue. They may not be sticking on those things, but it is a kind of so-called unsupervised learning. No one might have told them that you have this is a two-wheeler, this is a three-wheeler, this is a four-wheeler, and you have to separate like that. No instruction is given, no mapping is given, but still the people are doing it. I mean, kids are doing it. This kind of learning is called unsupervised learning. And when it comes to machine, we train the model such a way that given say the images of three fruits, it should give put all apples into one group, okay, all peer into second group, and so on. If that happens, we call it as an unsupervised learning, and the process of sometimes referred to as a clustering process. This is of a very significant use in business, in industry and business, where to identify type of customers, to maybe to sanction loan and kind of thing. Next. And one major bottleneck with the supervised learning is the availability of data. You need sometimes for some model building, not all, some model building, huge amount of data, and sometimes you hardly have few samples. With few samples, if you want to the system to learn things, there is another way of learning called semi-supervised. You have a limited number of labeled data, but we have a more number of unlabeled data. Means you have some images of fruits labeled as apple, but there are many images of apple without the label apple. And if that is given, and you have I mean, that learning is a different way of learning. We call it as a semi-supervised learning. Only when you jump into it, you will recognize what it is semi-supervised. And where do we use it? Mostly when you have a few labeled data, like for example, I have a set of say X-ray images, and in few images, an expert, that is a doctor, has marked it as that is a benign, or it is that some cancer is detected in the image. He might have marked it. So we call it as the image with a label, a ground truth. That is, something is there. And there can be, I have so many other X-ray images also without any marking. And if you want to build a system which recognize something from this image, how do I train? Normally in supervised training, I will use only the labeled one. Whereas if it is, we have many data without label, I will go for this, the third option, that is called the semi-supervised learning. Ma'am, next. Okay, so there's a third category called reinforcement learning. It is not there. And reinforcement learning, where it is similar to the way we learn, say, playing some games. We start playing, we end up in a disaster. We may get 1 or 2 points and we fail. And we repeat it. But by failing, we learn something. I failed because of something. So I got a negative reward. That is my failure. Okay. So you learn from the failure and you improve your performance. You change your strategy, play better next time. Again, you may succeed or fail. Again, if it is a success, you will mark it as a success, and that will be a positive stroke for you. So that you will remember as something like a positive experience. But next time, if again you fail, why you fail, that will become a negative thing. So this negative and positive things together will make you learn how to play the game. That is what is happening when you play some many what you call says even if it is chess or many other games. So this kind of learning is called reinforcement. We can do the same thing with the help of the machine. So that has become a popular model, and in almost recently there are several related works are coming in this reinforcement learning because of this what you call its effectiveness in many practical applications. I will end with this small introduction. Again, in machine learning, what is the current focus? Machine learning is not limited to any particular way of doing. For example, there are statistical classifiers, statistical way of classifying things based on probability. So Bayesian classifiers are there based on the principle of the statistics, or in probability principle. So those classifiers are actually built based by extracting the probabilities, and it is basically a computation happening. Okay, so that is a kind of algorithm, but there are a kind of algorithms where we don't have a see, if it is a statistical classifier, many a times you can write a program with some assignment statements, with some loops, and with some if statements. You can write a program, not very difficult. Whereas there is a kind of algorithms where where you cannot hardcore it. Hard code means you will not be able to use your if and if then else statement or loops to come for a solution. Loops, of course, loop is a different concept. But see, for example, suppose I want to identify tall students, the person with the problem I discussed earlier, tall students in a class, and if I say 160 is the limit, then what is the major problem with this kind of a solution? This is called hardcore. We will write a statement: if the height greater than 160, it is tall. But what is wrong in that? We don't do it ever, never ever we do. As a human being, we never ever we do that kind of a classification. We classify based on some approximations: who is tall and who is short. Okay, we will never measure the in inches or in centimeters and say X is taller. The problem with this kind of if statement is that even if your height is, say, my rule is 160 and 159.9 also will fall into the short category. Is it justifiable? No. That is why we have a kind of what you call algorithms or approaches which we put together. We call it as a soft computing approaches. So where there is no deterministic kind of algorithm, means the given an input, you can expect an output. That is a deterministic approach, isn't it? Always you give a 5 as input, you will get 25 as output, deterministic. But there are approaches where there is no such determinism, there is no such a code available where it will compute mathematically and give you a result, or it will perform a series of if statement and give you a result. No, that kind of algorithms. One typical algorithm in that category, which people started in early, in 60s, is the artificial neural network, which is based on our the functioning of our neurons. Maybe our system is very complex. Out of that very complex neural system, people started with a very minor concept, and they started building the particular kind of machine learning approach called artificial neural network, where it learns to perform different tasks. That also is a very huge or vast subjects with thousands of models. Okay, in that, when you focus on this neural network, you start with what is neural network. Very simple to learn. Only thing is, the last point will be that the only thing is you have to experience it. So start with the basic neural network. You build small networks and learn what is a neural network, and then you jump into the present day, the most popular machine learning set of algorithms called the deep learning concepts. So it is my point that maybe in another few years, people will be trying to solve most of the problems with this kind of deep learning, which is the only negative aspect is resource demanding. We don't have that much of resources at our hand, but luckily we have many tools. So then for this next, probably the last slide. So how do you master it? You are as a BCA or MCA student, you start early. You start as early as first semester, and you attend more courses. There is, if you go for NPTEL courses, they are theoretically sound but not very good from the practical point of view. There are Coursera courses, but sometimes the cost is high. And some institutions, they help you to do some courses. Some institutional arrangement will be there, but some audit courses and free of cost courses are there. You try go through such courses. You identify some faculty member, that is very, very important in your institution. Somebody, you just approach them, and they, so that in addition to this more courses and all, you require some physical or some offline kind of interaction. So for that, identify some faculty member, they will guide you through. And always it should be experiential learning. Nothing like a theory. Theory should be blended with the practical. So you sit with, see, for example, that is why sometimes, Python is a very simple language to learn. You learn Python. You basic you learn, you can easily jump into Python and you can start working on it. And many times, you have how do you find there are many open source softwares available for machine learning, and you have to identify, you have to go through those tools and identify which tools are there to start with. So Python environment provides many such tools. It's like a scikit-learn or PyTorch. So much of tools are available as part of your Python, which will help you to learn or implement machine learning algorithms. It's matter of maybe the only thing is the concept should be clear. Otherwise, it is the coding is very short, and execution time is more, or training time is more. But building a code is easy. But only request is that always learn what it is before you apply it. Okay, it is not like using sqrt function where it will give you the square root. There will be many parameters associated with your function. What are those parameters? Why am I using? What value should I give? If I change the values, what will happen? To understand those things, that is what is expected from in industry. You need not write any low-level code, but you have to use functions. But those functions, so much of arguments will be there, so much of parameters will be there. What parameters are them? How do I fine-tune it? What you know about those parameters? That is much more important. So you learn the theory, you practice it, and become a master in basically I say become a master in the deep learning concept. That is the demand of the present day. This is not the only demand. As earlier I said, there are many opportunities, but this is one thing which you can apply in IoTs, in security, in many areas, in web programming. All these concepts can be used. Okay, so I think I've taken more long, almost 1 hour. So with this, I'll stop. I have some more topics. I like try to attend these conferences, go through tutorials and blogs, but don't take all these blogs and tutorials as correct. So always, whenever you are in doubt, you refer to standard textbook. When I say standard textbook, you can see many textbook authored by Indians. I'm not degrading Indians, but still they copy from this internet and come up with a textbook. There is no plagiarism check in writing textbook. So some textbooks are like full of mistakes and conceptual errors. So don't believe in the blogs or tutorials as such, because you have to always be vigilant whether the resource is good, whether it is a reliable person who is writing the blog, like that. And textbook also go for standard textbook for reference, and you can use simple textbooks for examinations. Okay, so try to write more research papers and read more research papers, read more articles related to latest topics, and attend conferences and workshops, get yourself updated, and present your your contributions. And thank you for this patient listening for this last 1 hour. With this, I remain. Thank you all.
Thank you so much, sir. It was a very enlightening session, and your words were very much words of wisdom. Now I invite Dr. Neeta Thomas.
Thank you, sir. With all our due respect, on behalf of the management of Santhigiri College and Department of Computer Science, I extend our heartfelt gratitude for inaugurating ICACC 2022. Thank you, sir, for delivering such a stimulating and thought-provoking speech regarding NEP, how to begin a research, and also for explaining the latest trending technologies and learning methods. It will be definitely fruitful to all our participants. Sir, we really appreciate you taking out time for us from your busy schedule. Once again, thank you.
Thank you. Let me
Thank you so much, Neeta Miss. I thank everyone who have been present for this wonderful session. First of all, I thank our very own principal, Father Paul Parikatil CMI, for giving us such an opportunity, and our chief guest, Dr. Raju Sir, for the wonderful and informative, a very informative session. And thank you so much, sir. And I thank our head of the department, Ms. Amita Joseph, and the convener, Dr. Rashmi, and all the students and participants from our college and the faculties and researchers and the academicians who have joined us, who have spared their time from the part of the day to be a part of our event, to make it a very huge success. Thanks from all of us, from the bottom of our heart. We thank all of you for sparing this time for us. Now, by this, we have come to the end of our morning session. All the participants who have joined, who have registered their names for presenting papers, are requested to join their respective panel discussion links, which have been provided to you. And the afternoon session, we will begin with the technical session by Professor Dr. Anand Nair from School of Computer Science, Vietnam, by 1 p.m. today. And I request all the participants to join the same link by 1 p.m. today. So let us all rise for the national anthem.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्जल जगति तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे